Yeah, hi folks. This is a video for the GCSE Further Maths, and we're looking at some trig. Now, I know I've said I'm not going to go over GCSE stuff. You should be all over that, but I think this is a bit of an exception. We do need to be more secure with the trig stuff than you can get away with at GCSE. And the first things we need to know are that angles greater than 180 degrees exist. So when we do trigonometry at GCSE, we tend to focus on SOHCAHTOA right angled triangles, and that's fine, but angles greater than 180 exist and negative angles as a concept exist, which I know is a weird thing to get your head around. But if you go, my voice went there, excuse me. If you go into your calculator and you type sine 30, sine of 30 is a half. Fine, sine of 30 degrees is a half. But you can do the sine of 390 degrees, also a half. The sine of 150 degrees, also a half. You can get the sine for any angle. You can't maybe visualise a 390 degree angle or a minus 100 degree angle, but you can take the sine of it. So really, as a reminder, you can get the sine of any angle, and if you plotted the sine of angles on a graph, you get, and I'm going to do as neatly as I can, you get this shape, and it carries on. Excuse me, my voice is going. It continues on in both directions forever, and it goes between 1 and minus 1. This is quite a bad drawing really, because it needs to be, it would be symmetrical. We can plot it on the computer and we can see what a sine graph is. You can't see my computer at the moment, but we can do that. But the key points are that that's 360 degrees, that's 180 degrees. This is my angle in degrees. Halfway, 90 degrees, so the sine of 90 is 1. That must be 270 degrees, so the sine of 270 is minus 1. And these graphs are symmetrical. I wonder if I can I might try and draw that again. Let's try and draw it again and be a bit more scientific about it. I'll do it by measuring. I can't measure squares because these squares are 0.7 millimeters, which centimeters, which are 9. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Just off the end there. So if I go there, this will be a bit better. Okay. That looks a bit more like. And it would carry on, as I say, forever in either direction. So if that's theta in degrees, that's sine theta 1 minus 1. So minus 90 has a sine of minus 1, 90 has a sine of 1, 180, 270 goes down to minus 1, 360. And we can check the sine of 90 is 1. I typed sine 90 and I get 1. The sine of 180 is 0. The sine of 270 is minus 1. Now I don't know what I don't know what this will be 450, won't it? I don't know what a 450 degree angle looks like, but I know that the sine of 450 is 1. I don't know what a minus 90 degree angle looks like, but I know the sine of minus 90 is minus 1. So we need to know about sine graphs. We need to know about cosine graphs. We need to know the shape of a cosine graph. Try and draw it a bit better. So if this is my angle in degrees, cosine of 0 is 1. Let's go down 5. Okay. Let's see how this goes. That's quite good, quite pleased with that. A cosine graph is the same sort of wave shape as a sine graph. But look at the sine graph. The sine graph goes through 0, 0. Starts at 0. The cos graph goes through 0, 1. So that's cos theta. Same key angles, 90, 180, 270, 360. Now that may, I hope it's not, that may not be brand new to you, but we do need to know these shapes. Minus 90, minus 180, minus 270, minus 360. Okay. For completeness, we'll do a tan graph. Don't often get tested on tan graphs, don't often use tan graphs, but, you know, we should know about a tan graph, really. So a tan graph is an odd one. 90, 180, 360, 270. Now, a tan graph is discontinuous. That means that it has a break, it has breaks in the line. It goes up like that. It never quite touches that dotted line. And it does that. It's odd, it's an odd graph. Never quite touches. Zero, 90, 180, 270, 360. So while a cos graph and a sine graph oscillate between 1 and minus 1, a tan graph just repeats every 180 degrees. So if I know the tan of, let's say, 50, that's going to be the same as the tan of 230. I'm sure that's what you were saying in your head. Equally, it'll be the same as the tan of, what's going to be the same as the tan of? I'm going to go back 180 minus 130, or minus 310, or 410. Just repeats every 180 degrees. So let's say I want to solve an equation using the graphs. I'm going to solve this one. Solve sine x equals 0.6. Now, if I just left it like that, looking at my sine graph, there's an infinite number of solutions to that question. 0.6 will occur infinitely in either direction. So when I see these equations, the equations will be clearer. It will usually say something like x is between 0 and 360. Okay, well, my calculator does inverse sine. Don't forget, my calculator gives me the solution that's nearest to 0. So x equals the inverse sine of 0.6. Remember, that's in yellow. Shift inverse sine 0.6. 36.87 degrees. But don't forget, not only is it there at 36.87 degrees, there's another one there. 36.87 is that distance from 0. So if I come backwards that distance from 180, I'll get the other value. So I do 180 minus 36.87. And I could keep going, but of course the next one is going to be greater than 360. But to get the next one, I would just add on 36.87 to 360. And then I'd add on whatever that answer that is, add it on because it repeats every 360. But because I'm only going between 0 and 360, they're the only two answers that I want. So 36.87 degrees, 180 minus that, 143.13. As it happens, for sine theta equals, let's say, alpha, theta is whatever the calculator gives me for that, and 180 minus whatever calculator gives me. So to solve an equation that requires inverse sine between 0 and 360, there are two solutions. If it was between 180 and minus 180, sorry, if it was between 0 and minus 360, you just need to look at the shape of the graph to decide what you've got to do. So we use these graphs. What about, let's try another one. Solve 3 cos x equals 2 in the range 360. Well, I'm going to divide both sides by 3. That's not a surprise, I don't think. The calculator's going to give me one value. Cos minus 1 or 2/3. Okay, inverse cos 2 over 3. 48.19 to 2 decimal places. And also on a cos graph, so 48.19, let's say that's there, I can see there's another solution there. That distance is 48.19. That means by symmetry, that distance is 48.19. So for cos, I take away from 360. So 48.19 degrees and 360 minus that, 311.81 degrees. And they're both to 2 decimal places. I should have written that for my previous answer. So the calculator always gives me the solution closest to 0, be it positive or negative. Now with cos, I can see that there is a negative angle, and because all these things are symmetrical, if that's 48.19 there, that would be minus 48.19. But of course I don't need to write that solution because it's not in the range that I want. So the law here, cos x is the same as cos 360 minus x. Let's write this one a bit better. Sin x is the same as sin 180 minus x. So solving equations with trig in, we need to be careful that we're getting all the solutions to these equations. Okay. What about this? Sin x equals minus 0.3. Again, we'll go between 0 and 360. Well, let's look at my sine graph. Minus 0.3 down there, it's going to be a negative value. But I don't want that. The calculator's probably going to give me that. I want that value there and that value there. Let's see what the calculator gives me. If I go inverse sine minus 0.3, it gives me minus 17.5. Well, that's telling me that that distance from 0 is 17.5, so I can go that distance from my crossing point, 17.5. Let's try that. The calculator gives me minus 17.46 to do decimal places. I actually know my rule for sine. It still counts. I do 180 minus it because, of course, even though it's a negative value, 180 minus a negative value means you add it on. So it still works. 17.5 that way, so I'll go 17.5 that way. I also want this point here, and actually, of course, what I can do is just add on 360 because the sine graph repeats over 360, so that point there corresponds to that point there. It's on that upward slope, it's 360 degrees later. So it still works. 180 add 17.6, 197.46, and then I know there's another one, and I'm just going to add on 360 to that. So add 360, 342.54 degrees, and because x needs to be between 0 and 360, I'm actually going to cross that one off because I don't want it as part of my solution. So because it repeats every 360, I got that one. 180 minus 17.46 is 197.46. Again, I'm using the shape of the graph to see what I expect. Okay, have a go at exercise 1. I'll put the answers up at some point. Let me know how you go on with that.